this is Vidura. I want to make this video as a commentation from the self-oscillation of the coils that I had observed. Now this is the charging battery set. They are actually 32 volts, I think. And these are the RAM batteries. Now I will connect to show you this effect, this surprising effect. But I will first switch the meter to, this is now 250 volt range. I will go to 600 volt range directly, because we will see there is a huge voltage rising. Now I will tap. I use 24 volts only. Okay, because I don't want to fry the components of the board. You see, I have here in each back EMF side two UF5408 diodes, and they become really hot. Now you will see it needs only one switching pulse, and immediately the neons goes very bright. And you see the voltage here, we are about 500 volts already, it's still rising. Now I will cut for not to damage the parts. You see, 600 volt range, it goes up to the top of the scale. Okay, now I have hooked up the scope probe. Here this is in the wire of one of the coils, which is the drain of the transistor. And the probe is in 1 to 10. I don't have a high voltage probe because it goes almost out of range with the voltage. You will see when I put in oscillation, I have about 2 megahertz very sharp spikes, and it's shooting over the scope. We'll cut to not to damage the parts. So this seems really not to be a normal coil oscillation, and note that I use normal soft iron as chokes in these coils. At my guess it has to be a kind of longitudinal phenomenon. I'm sorry, the frequency was about, it's in 2 microseconds and 50 volt per division. It's about 500 kilohertz, the oscillation. Okay, now I will repeat again. I put here, it's a Hall effect clamp meter. So you can see the current which is drawn. We'll connect and set up the oscillation again. You see just one switching pulse and it immediately the coils oscillate. You can see in the scope 500 kilohertz spikes, and the current drawn is 2.3, 2.5, 2.6 ampere. I wanted to note you this detail. I have here 5 470 microfarad caps on the power inline. which when switching produces a very sharp disruptive discharge, similar to the Tesla coil effect. When I was checking this effect, which me took to my surprise because it was really not what I looking for, I found that the wire from the photodiodes from the signal input acts as an antenna, which couples to the coil and produces a resonant oscillation. So I was looking to stop this effect because the motor actually don't run this way. All the energy is irradiated. So I add some decoupling capacitors, and immediately the motor runs normally. So here another test now with the oscillation problem fixed with the decoupling capacitors. I will test the normal run mode of the pulse motor. Now the instrument is in 50 volt range. The batteries are sitting like 34 volts. They have received a good amount of charge in a few seconds from the coil oscillation, as they were around 28 volts before. So now I'm running the motor in 36 volts. I put the 3 batteries connected, and I leave the scope hooked up in the same coil than before. So I'll give a little spin. You see now in the scope just a normal driving pulse. I have to go down with the frequency. 36 volts. And the charging side, you can see it's now in the 50 volt range, 3 batteries, and with 35 volt actually. Slightly charging for the Bedini effect from the back EMF. Here the quite normal pulse, and you see the charging batteries rise to, we are in 38 volts now, so there has to be some back EMF.